Okay, so in this video I'm going to look at problem 1 from the first homework set. So in this problem you're asked to compute 3 different limits, which all require slightly different methods in order to evaluate. So part A, we have the limit as x approaches 3, x cubed minus x squared minus 6x divided by 2x squared minus 4x minus 6. So the first thing to notice is we might check, is this function continuous? Can we just plug in x equals 3 to both the numerator and denominator to get the value of the limit? But you'll see if we try to plug in 3 to the denominator, we'll get 18 minus 12, which gives us 6, but then minus 6, which gives us 0. And similarly, you'll see that the numerator is 0. So we cannot just plug in x equals 3 for this problem because the limit would look like 0 over 0, and that's not a form that we can evaluate easily. So instead, we'll have to do some manipulations to simplify this. So the first thing to notice is that in the numerator, there is an x in every term, so we can pull an x out front. And similarly, the denominator has a factor of 2 in every term, so we can make our lives a bit easier in factoring by pulling a 2 out. So if we make those simplifications, we'll get limit as x goes to 3 of x times x squared minus x minus 6 over 2 times x squared minus 2x minus 3. Now we have 2 quadratics, so we can factor those. This becomes the limit as x approaches 3 of x times, let's see, this will have x minus 3, x plus 2. And in the denominator, it looks like we'll have x minus 3x plus 1. And now we have an x minus 3 in both numerator and denominator, which can be canceled. So this simplifies to limit as x approaches 3 of x times x plus 2 divided by 2x plus 1. And now neither numerator or denominator is 0. This function is continuous. We can use our limit laws to distribute the limit to both numerator and denominator and then just plug in x equals 3. And when we do that, we'll get 3 times 5 divided by 2 times 4, which gives us 15 divided by 8 for the value of the limit. Okay, so the next one asks about the limit as x approaches infinity of 4x to the 5th minus 3x divided by 2x to the 5th plus x to the 4th minus 3x cubed plus 1. So if you remember the coefficient trick for these sorts of polynomials, you can probably immediately see that the limit is only going to depend on the leading order coefficients, which gives us a value of 2 as x goes to infinity. But I'd also like to go through and show you how you could derive that with it if you didn't remember that trick. So the first step is to divide everything in both numerator and denominator by the highest power of x. So when we do that, we get 4x to the 5th over x to the 5th minus 3x over x to the 5th divided by 2x to the 5th over x to the 5th plus x to the 4th over x to the 5th minus 3x cubed over x to the 5th plus 1 over x to the 5th. And so now why have we done all of that? Well, if we simplify this a little bit, cancel some factors of x, we'll see that this simplifies to the limit as x approaches infinity of 4 minus 3 divided by x to the 4th divided by 2 plus 1 over x minus 3 over x squared plus 1 over x to the 5th. Now we can use our properties of limits to distribute the limit to both numerator and denominator. The 4 and the 2 don't have any x's in them, so those are left alone when we do that. But everything else is a constant divided by x. And as x goes to infinity, we're dividing by bigger and bigger numbers, so these quantities over here all go to 0. And we're just left over with 4 divided by 2, which is 2. And again, we could also have seen this immediately from the coefficient trick if you prefer to use that. Okay, so for the last part of this problem, we have a limit as x approaches 0 of 1 over x times x plus 1 minus 1 over x. And on their own, both these limits are difficult to evaluate because we'd be dividing by 0. So we can't, for example, split it up into a difference of the two limits using one of the limit properties, because the limit as x goes to 0 of this does not exist, the limit as x goes to 0 of this does not exist. So we have to do some simplification of this quantity inside parentheses before we can deal with the limit. And the way we can do that is to find a common denominator for these two things. So we have a limit as x goes to 0 of 1 over x times x plus 1 minus x plus 1 over x times x plus 1. So I just found a common denominator for this second term. And this is equal to the limit as x goes to 0 of 1 minus 1 cancels out, so we just get negative x divided by x times x plus 1. And if we simplify this, we get limit x goes to 0, 1 over x plus 1, which gives us 1 for the value of the limit.